So starting with that word factor, I briefly mentioned it. We are referring to, we're going to say undo multiplication. Right? The easiest way to think about that is that since we have a bunch of sixes up above, factoring 6 would mean writing it as 2 times 3, right? We are undoing a multiplication. That's what I mean by that. So let's look at something like this, 5y squared plus 10y. First thing we want to do is identify that greatest common factor. So what is, someone raise your hand. Johnny, what's the GCF here? 5y. 5y. All right. So once we've identified it, we then want to write it on the outside of a set of parentheses. Okay? So then we have this set of parentheses. And then on the inside, we simply want to write whatever is left over. So if we take out 5y, what is left over? We're essentially dividing it out. Good. There we go. So then what are we going to do? Write what is left over. Or another way to say that is divide out the GCF. Right? How can we check to make sure we did this correctly? In math, we always have a way to check, Dawson.
We'll distribute 5y.
There you go. Distribute and check. And I would just do that mentally, right? That's not something you actually need to write down. Just do a quick mental check. Oh yeah, 5y times y is 5y squared. 5y times 2 is 10y. You're done. Yes?
What about the one with like the trees like that?
You're thinking prime factorization. So you can do that to come up, you would use that to come up with your GCF of the numbers, which you're welcome to do, but I'll let you guys do that on your own. All right, let's just do one more together, and then I'll put a bunch on the board. So someone raise your hand. What is the GCF of this trinomial, this quartic trinomial? Just the GCF. Is that a hand up, Dawson? What is it? Wait, well, I want you to tell me.
I think it's 3x.
Okay. Do we agree?
Yeah.
I agree. It's 3x. Now, somebody else. If we divide that out, what is left over?
4x to the 4. Yes. 4x to the 3rd.
You're taking away
minus 2x plus 1.
Yes. Okay. This plus 1, and this is why I added this problem. This plus 1 is going to be a common mistake, right? Because what you're doing, you are dividing out the GCF. So something divided by itself is 1, not 0. The common mistake is going to be just forgetting to write the plus 1, ending this after 4x cubed minus 2x. Now you quickly can see that's wrong. If you distribute, you would very quickly find out that it's wrong. But oftentimes we don't check our answers, so we don't realize a simple mistake like forgetting the plus 1. All right. This is going to be one of the most common GCF factoring mistakes. Is right here. So let's put this to work. All right, Jack, what is the GCF of part A? Just the GCF.
X squared.
There we go. So then we're going to fill it in. Felix, what goes on the inside of the parentheses?
2x, and x. 1.
There you go.
Oh, I did it differently.
2x plus 1. There's only one way to do it. You should end up with this as your answer. Nothing else.
Can you just do x?
Yes, but that's not the greatest common factor. That's just a common
Oh, yeah.
Lily, what about part B? What did you write as your common factor, your greatest common factor?
Negative 3y.
So negative 3y and 3y are both correct. You should use negative here and in part C. And I would go ahead and use factor out the negative if your leading coefficient is negative. So if your leading coefficient is negative, factor out a negative. Now, what is the leading coefficient, everybody, for part B? I'm just curious. call out?
Negative.
Negative 9, right? That's the leading coefficient. So because it's negative, I would factor out a negative, which in this case would leave us then with a 7 plus 3y squared. You can also rewrite that as 3y squared plus 7, so it's in the standard form. When you're factoring, it's not quite as important. All right, next one, a common factor. Hannah, what'd you get the common factor for part C?
2x squared.
Yeah, 2x squared. And as I said, it doesn't matter, but to be consistent, we're going to take out a negative here. It's okay if you didn't. We're just going to change your signs. Yes?
I've got a question about A later.
Okay. Sam, if we take out a negative b, did you take out a negative 2x?
Yeah, I
squared?
did.
Okay, what'd you get?
4x to the 7th plus 3x squared minus 9.
There we go. If we're ever unsure, distribute to see if it works out. If for these three, if we distribute, they go back to where we started, so that's a good sign. Yes?
Alright, if we take out a positive 2x squared, would it still be?
It's still corrected, but your answer then would be negative 4x to the 7th minus 3x squared plus 9. Yes.
For A, couldn't you have x 3, and then instead of you'd have x minus to the power of minus 1?
Yes, but we don't want to end up with negative exponents here, and we don't want to end up with a fraction writing that has 1 over x. So that you could do that, but there's really no need. You only want to take away what there is currently here, right? There's 2 x's here, so take away 2 of them. There's 3 here, but only 2 of them match. So x squared is your greatest common factor. You can take away 3, but you don't want to, because then you end up with negative exponents that you don't want to deal with. Dawson, next one, greatest common factor. What'd you get?
9x to the 3rd.
All right. There we go. And Ellie, when we fill in the parentheses, what should we get?
2x plus 4x minus 1.
There we go. Should look something like that. All right, so this is factoring by GCF. Now, that's all we're doing today is factoring by GCF, but it's going to look different. So in this next one, we're going to factor out a common binomial, and it's still a GCF, it just looks different. So let's look at 2 different examples here, and they're really the same thing. So let's say that we have 7x plus 2yx on one side, and on the other, let's say we have 7z plus 1 plus 2y z plus 1. Somebody tell the whole class, how do you factor the left side? Ignore the right, ignore the blue. How do we factor just this? David?
Just x on the outside, and then the 7 plus 2y.
There we go. X times 7 plus 2y. That's how we factor the left side. The right side is the same thing. It just looks different. So we have here, this is what we would call our common binomial. It is the same, right? There's that word common. So it's the same in both terms. Just like this x was the same in both terms. Because the x was the same, you could factor it out, write what's left over. It's identical if it's a binomial. So because your binomial is the same, you can factor it out, z plus 1. And then simply write what is left over. In this case, you're going to be left with a 7 plus 2y. It looks completely different, but it is in fact the same type of factoring. It's okay that these are binomials. They're the same in each one, so write them out front. And then in parentheses, simply write what is left over. Yes?
Can you just leave it without using it?
Nope. And then this is your answer. Because remember, you might want to FOIL, right? Is that what you're thinking?
Yeah.
Yeah. But we want to undo, essentially what we're doing is undoing FOIL, right? So factoring leaves us an answer like this. Whereas before, we would have kept going. All right. All right, volunteer part A. How can we factor this with our common binomial? Kelly?
X plus 6 in parentheses then 4x minus 5.
There we go, x plus 6 times 4x minus 5. We factor out our common binomial of x plus 6. Next one, Alex.
2x plus 3 and 7x plus 1.
Yeah, this plus 1, once again, that's going to be a common mistake. Forgetting to write the plus 1. When you divide something away from itself, you get 1 out. Alright, our next one here. Oh, question?
Yeah, for 7, can you like reverse it with 7x plus 1 at the beginning?
Yes, order doesn't matter in multiplication. So, yeah, either way you write it, if they're both equally correct.
Okay.
Part C. Sam?
It would be y plus 4 times 3x minus 2y.
Alright, there we go. Factor out our common binomial of y plus 4, and we get this. And then lastly, let's take a look at this. Our common binomial actually isn't a common binomial, right? So we can't factor right away. These are not the same thing, but they're almost the same thing. They're opposite of each other. So if this is a problem where we actually need to factor twice, really, or just think about it in a different way. If we rewrote it like this, 5x times 5x minus 2, and then if we took out a negative here, if we factored out a negative, the 5 would become positive, the 2 would become negative, this would become minus, and then 5x minus 2. We're allowed to do that. All we did was take out a negative. Think about it. We just have to distribute to get back to where we want. So distribute the negative, we get back to part D, which means we did it correctly. And now we have this common binomial, and it actually is the same. So 5x minus 2, 5x minus 1. Once again, the order doesn't matter, so you can flip them around, that's fine. Yes?
So all you can do is take the negative one, and can you just take the negative one and write it out?
Oh, yeah. You can do that. Alright, so let's put these two things we've talked about today together into what we call factor by grouping. So I want you guys to write this down. And you should notice, once you write this down, now the methods we just talked about won't work, right? The GCF of numbers and variables and the common binomials, those can't work for this. So what do you guys notice about this? This is a cubic polynomial. What do you guys notice about it? Mm-hmm.
The 7 and 8, or 8 is the greatest common factor of 56, and 7 is the greatest common factor of 49.
All right, so if we group these together, right, that's where that name comes from, we actually can do some GCF factoring. So let's split it in half in our minds. We're going to split this in half. And then we are going to do some GCF factoring on each side. All right, so we can see that not only 8, but actually 8x squared on the left is in common, 8x squared. And we write what's left over, which would be an x plus 7. On the right side, we have a 7 that's in common. So then we'd be left with an x plus 7. Now, we're cutting this down in the middle of an addition problem, right? So make sure that that plus follows us. And now it looks just like example 2, where we have a common binomial of x plus 7. So then we would go ahead and factor the common binomial. So this would become x plus 7 times 8x squared plus 7. All right, Alex, on the left side for part A, what's our GCF and how does it just the left side factor? Yeah, let's take out a positive 5n. It'll make it a little bit easier for us. You do get the same answer though. There we go. Left with a 5n minus 1. Porter, what about the right side?
2.
So let's take out a positive, it'll make it easier.
2.
What's left over?
And then 10 plus 1.
So take out a 2 from 10, or divide 10 by 2, I should say.
5 then.
Yeah, and since I changed your sign, it'll be a minus 1. Having things positive for as long as possible is going to make our lives easier. And then our answer becomes 5n minus 1 times 5n squared plus 2 by taking out our common binomial here. On the right side with part B, Parker, what can we take out of 18x cubed and 15x squared?
3x squared.
And what does that leave us with?
6s minus 5.
There we go. And if we want the same thing, if you take out a positive 7, you don't get that, correct? If you take out a plus 7, you get a negative 6 plus 5. Are those the same thing? No, so that doesn't work. So make sure you take out a negative 7 here, because that will leave us then with a 6x minus 5, which is exactly what we want. We now have a common binomial. Factor it out. 6x minus 5. 3x squared minus 7.